Hey, so since we've talked about collision and a bit of physics in the previous video, I thought it would be a good idea to talk about sweeping in this video as well, before we move on to pawns and some of the other sections. So again, a lot of what we do in these videos applies to what we'll be doing in upcoming sections. So pawn, for example, inherits from actor. So again, a lot of what we discuss here applies to some of the upcoming videos as well. So let's go over to the .cpp file, and in the tick function under the super tick, I'll add something called fHeat_result, and I'll just call that hit. So this fHeat_result, I'll just right click on it, and then I can do peak definition. And as you can see, it says structure containing information about the hit of a trace, such as the point of impact and the surface normal at that point, and so on. Now if I scroll down, you can see you have this here, this uint8, and this indicates if this hit was a result of blocking collision, and so on. So you can see that Unreal Engine treats this uint8 as a boolean. So oftentimes when you see uint8, this is treated as a boolean in Unreal Engine. Just a quick note on that. So I'll scroll down here, so you can see f_vector location. So this f_vector underscore netquantize basically inherits from f_vector. So it's basically just an extension of f_vector. And as you can see, we can get the location. You can also store that location in an f_vector, as we'll see a bit later. And you have a bunch more properties here. So what I'll do is I'll do add active world offset. Now we've seen this sweep before, but we didn't know how to use it. So okay, so in these parameters, you can see it's set to false by default. Okay, so first I'll pass an f_vector, and I'll just do 1 in x, and I'll leave y and z to 0. So I want a small amount of offset with each frame. And I'm doing add active world offset instead of local offset, mainly because of how the chair was set up previously. And I'll show you kind of why when I open up the editor in just a second. So in this case, we want to set the bool sweep to true. So we want this to sweep. So what does this sweeping mean? Well, what we do with sweeping is we basically check, right, along the way as the actor moves from one position to another, we check or sweep along the way, and it will trigger overlap events. So we need collision to be set up properly, otherwise this will have no effect, and sweeping also only applies to the root component. So this again is one way of how we can set up collision or overlap, right, have those overlap events set up even if we have physics turned off, because sometimes we don't want physics interactions. Okay, so that is what this is about. If you have physics turned off and you still want things to collide as they move around in the world, then you can do this programmatically using sweeping. We can actually store that information. The third parameter here is fHeat_result. You actually have that eTeleport type parameter right at the end, but we're not concerned with that for this video. We just want to store the heat result information. I just want to show you like how you can do that if you want to access that information later on. But you can see the weird thing here is this is a pointer. So how do you initialize a pointer? It stores an address, right? You initialize a pointer typically to some address. And of course you use the address of operator to access a variable's address. Okay, so now this will store that information, that hit result information, into this hit variable that we've created. So before we move on, and before I actually build this and run the editor, in the previous lesson I added this add impulse. So you can just remove this line, or I'll comment that out. Okay, so that is all I want to do for now. I'll just do Ctrl F5 to build and run this. So if I click play now, you can see that we will have some physics. So this falls down to the floor. This is not really what we want. We want to turn off simulate physics. Then this will become a kinematic object In other words, it's only going to move where it is told, so programmatically. So okay, so I'll turn off simulate physics, and if I go and play and simulate this now, you can see we get some collision. That chair will now collide with this object at the back here. You can turn on collision, okay, and you can see this wall will also have collision actually. I'll turn that off, and I can select this back piece. So again, to make sure that your objects have collision, you can click on it, find it in the world outliner. Maybe you can browse to that asset, so Control B or left click on browse to asset. In this case, this asset is actually under the engine content, so I'll just double click on that, and you can see that shows up. Now I can show simple collision, and you can see the green outline where that collision is. So this is fine, this has collision. If your object does not collide, then just make sure that both of your actors actually have collision applied. So I'll just select this actor again, and you can see where X points. That's why I set it up to world. If I click on local, X will point now in a completely different direction. So what's useful about storing this? Actually, if I cut this out here, you can see hot reload complete, and if I simulate, you can see we still get the results that we want. Okay, so we are updating its position programmatically, but we can still trigger overlap events and we can still have collision without having to simulate physics. So I'll stop that. So I'm just showing you this so that you can see you don't have to pass this in for this to work. You can just set this to true here. But what is useful about passing that hit in, I'll just paste that back, is now that we have that information, we can access that. You can do so here we can access now the members of that struct. So you can see again, this here is a struct. Right click on it, and peak definition. You can see this is a struct. You can actually just hover over it as well. It's a struct. Okay, so now we can access that using the dot operator. This thing here is not a pointer. We are simply passing the address of that in here because this parameter expects an address. So again, you can do dot here, and then you can do location. And if you remember, again, going back here, go to definition. So you scroll down. Now you can access things such as this location that I talked about. And this is the location in wall space where the moving shape would end up against the impacted object if there is a hit. So that is how you can access and use that information. I just wanted to show you like how you get that information back from this function, right? And this is how you can do that. I'm not actually going to use it here, but I just wanted to, again, to highlight how you can get that information. Okay, so back in Unreal Engine, what I want to refresh your memory about is if you select the actor, you scroll down to collision, you have these collision presets. So I'll click on this drop down, and then you can select something like custom, and then you have all of these settings. I'll select this backdrop actor and go to collision. You can set that to custom as well. This is set to world static. Now typically when you have an actor that moves around in the world, you want to set this to movable. Okay, so just remember that. This was set to movable actually, but if I remember, if you set this to static and you play this now, nothing will happen, okay? And you'll actually get errors as well. So what you need to do is you need to select that actor and set this to movable. Okay, so I'll scroll down to collision, and you can see it is set to world dynamic. So this means that this actor will move. Basically, it's dynamic. Okay, it's not a static or non-moving object. Whereas the wall at the back, if I select that, this is a static object. So you can trigger overlap events here. you can block all. So in this case, it's going to block everything, or you can ignore. So let's say if we ignore wall dynamic now, right? And I click play now, you can see my actor moves, but it's going to go through that wall. Similarly, I can change that around. I can have the chair selected and I can ignore static. So I can ignore static and I can set the wall, click on the wall again, and I'll block all. And even though it's blocking everything, that chair will still move through it. So you can see, if I select the chair again, set that to block, wall static, click play, then the chair will go and the wall will block it. So just a reminder of how this works. As you can see, it's not that difficult to set up, and you can go and block and ignore and overlap, these various object types. You can see you have pawn and physics body and various other things as well. Okay, so I think that is going to wrap things up for this video. I just wanted to demonstrate how sweeping works. And the main reason for this is, let's say you build a game where you have like a pedal or something that you move, left and right on the screen, such as Pong or something like that. There are various ways of doing that. Okay, you can do it programmatically. So I have an example in mind that I'm prototyping for a project, an upcoming project for this course. Just a small project. And instead of using sweeping or physics colliders like at the end of the screen, right, if you want that thing to move to the left and right. So this, for example, let's say this chair has to catch balls or something. You want to move it to the left and to the right. You can have blocking volumes to the right and to the left. You can use sweeping, or you can do it programmatically. So you can say that you don't want it to go beyond, a certain position based on kind of trial and error. So you kind of eye it over here, check the location, and then, set that programmatically so that it does not go beyond that. Okay. So the point is you have various options and techniques of getting things to function the way you want. So in this case, it's just a simple example, but as you actually go in and prototype small projects, you will have these various options at hand, and then you can kind of decide whether you want to use physics or sweeping or do everything like programmatically.